Hey everyone, Morgan here. So we are going to kind of switch gears and now start looking at some formula problems. And we are going to draw a distinction between empirical and molecular formulas today. And an empirical formula is a formula that is reduced or represents a simple whole number ratio. Of the atoms in a compound. Whereas a molecular represents the actual formula of a chemical compound. Okay? And we need to really remember that chemical formulas are mole ratios. So you can have differing numbers of atoms that have the same ratios. And that's why we have empirical versus molecular here. So there are a lot of compounds that are going to have the empirical formula of CH. You can have C2H2. You can have, C4H4, C6H6, okay? But you need to know its molar mass to know which one we're actually talking about. So, carbon has a molar mass of about 12 and hydrogen is about 1. 12 plus 1 is about 13. If the molecular weight of the compound we're interested in is 78, and its empirical formula is CH. 13 goes into 78 6 times. That means C6H6 is the compound that we're talking about. Okay? Now, HCO2. Okay? Hydrogen 1 plus about 12 for carbon. Now, for the oxygen here, okay, we got 2 of them, so it's going to be 32. So when you add all this up, we're getting about 45. Now 45 would go into 90 twice, so I'm going to double everything here and get H2C2O4. And right away I'm recognizing the oxalate ion in there, C2O4 with a 2 minus. So I think I've done that correctly. NH2Cl, so nitrogen, I've got a 14. Couple of hydrogens, that's 2 plus a 35.5, that 51.45. Okay, now 51.45, that's going to go into that choice basically. Okay, so I'm doubling everything here. N2H4Cl2. Okay, I got a 12 for the carbon, I've got 2 on the hydrogen, and I got a 16 here. So that's 30 now. 30 goes into 186 times. So C6H12O6. And I think you get the idea. Okay? This was something you were pretty good at last year. All right. So define the percent by mass of carbon in CH4. Let's add up the molar mass. Carbon times 12.01, hydrogen 4 times 1.01, and that is 16.05. So carbon is 12.01 out of 16.05 times 100%. That comes out to be, 74.8% carbon. So then actually I just know that it must be 25.2% hydrogen automatically, okay, because they have to add up to be 100%. Now if you were going to do this for hydrogen for this next compound, actually pause the video and do it. Okay, you're back now. Let's see how you did. Phosphorus, 1, times, that's 30.97. Hydrogen is 3 times 1.01. Oh, actually, that's going to come out nice and even. So 34.00. So the hydrogen is 3.03 out of 34.00 times 100%, and that is going to be 8.9% basically. Okay, so pretty straightforward here. All right, let's go on. Let's look at page 8. Now, in the past, we have done some of these empirical molecular formula problems, and they weren't too bad. So I'm going to do a little bit of review about them with you today before we move on to what you're more likely going to have to do, which are combustion problems. So you had 4 steps last year. Change percentages to grams. That was pretty easy. Change grams to moles. You need to divide by the smallest number because you need a ratio. Okay, and then you have to make sure that you write a whole number ratio. So you might have to be multiplying by some type of a factor there to make that work. Okay, so we're going to do a couple of problems here just to illustrate that. So here we've got something that's 24.27% carbon, 4.07% hydrogen, and 71.65% chlorine. So 24.27 grams carbon, I just assume 100 gram sample, that becomes easy. 4.07 grams hydrogen and 71.65 grams chlorine, that's step 1, nice and easy. I can say 1 mole of carbon is 12.01 grams carbon. 1 mole hydrogen is 1.01 grams hydrogen, and 1 mole of chlorine is 35.45 grams chlorine. Equals, and I'm getting 2.02 moles carbon, 4.03 moles hydrogen, 2.02 moles chlorine. That ratio is pretty obvious. I'll divide by the smallest number. 2.02 equals 1. 2.02, that equals 2 basically. 2.02 equals 1. CH2Cl. Okay? Now, CH2Cl has a molar mass of about 49, about 49.5. Okay, grams per mole. Now, if I'm at 98.96, call that 99 over 49, that equals 2, C2H4Cl2. Now let's talk about previous knowledge, okay? This is called dichloroethane. Could you have figured that out? Could you figure that this was C2H4Cl2? Probably. Okay, so, okay. I think we froze up there for a second, folks, but I think it's back now. Okay, so let's move on. Let's look at the next one, okay? And I've got a couple little things that I want to point out in the next 2 problems, okay? Now, in this problem, I'm telling you that you have 30.4% nitrogen, or 30.4 grams of nitrogen. Now, you should know that you've got 69.6 grams oxygen. That should be kind of obvious, okay? They have to add up to be 100% times. nitrogen, 14.01 grams nitrogen, 1 mole oxygen. Here we've got 16.00 grams oxygen equals 2.17 moles nitrogen, 4.35 moles oxygen. Divide by the smaller 2.17. That's finding a ratio, and that's just beautiful. Okay, now that's also kind of a problem. They're not always beautiful. So that's about 46 grams per mole. Now 92 divided by 46 equals 2, so I need to double this, and 204. And you know what? They're not always that clean and beautiful. We need to understand that. So in this next one, 40.92 grams carbon, 4.58 grams hydrogen, and 54.50 grams oxygen times 1 mole carbon is 12.01 grams carbon. 1 mole hydrogen is 1.01 grams hydrogen. 1 mole oxygen is 16.00 grams oxygen equals. Now, when I ran some of this through my calculator, I got 3.41 moles carbon, 4.53 moles hydrogen, and 3.40 moles oxygen. That's basically the same number. So we'll just divide by 3.40. Equals 1. But this equals 1.33. So to get that into the whole number ratio, I need to multiply everything here by 3. And I get C3H4O3. That molar mass is about 88. 176 over 88 equals 2. C6H8O6 for my formula. And I can pretty much guarantee you that in an actual exam situation, they're going to make sure you don't get nice, pretty numbers. One of them is going to come out looking like that. Okay, folks, that's your end of page number 9. I'm sorry, page number 8. And this will be Morgan signing off.